To start off, we have here faults and earthquake. What is the definition of a fault? In your frame there, or in your module, a fault is a fracture or zone of fractures between two blocks of rock located on the Earth's surface. Okay? In defining fault from this phrase, a surface or narrow zone along to which one side has moved relative to the other. If we recall our knowledge in earth science way back when we are still grade 7, I'm not sure if you are discuss it with your teacher there. We define fault in the grade 7 as any discontinuity of the lithosphere. Or simply, fault is the boundary between two plates, right? Two tectonic plates creates a fault. And if two tectonic plates will create a tremor in these faults, that's the start of an earthquake. That's the start of uh, the natural phenomenon known as earthquake. And what follows earthquake? Different happenings like tsunami, landslide, avalanche, depending on where the earthquake originates. But we can trace the origin of the earthquake from a fault. No? Probably there's a pun that goes like this. It's his fault. Something like. But it's in its real sense, fault creates an earthquake. Again, fault creates an earthquake. But not all faults are giving us a natural phenomenon which is destructive in its sense. It also gave us beautiful landforms like volcanoes, mountains, valleys, hills, trenches, ridges. These are different landforms that is generated by the movement of the tectonic plates along the fault. There's a fear from those who live in Manila that if this fault will move, then everyone from the place there will be sunk since that place is a reclamation area. No? That fault located in Manila is the West Valley Fault. The most famous fault is located in California. Was it in California? There's even a movie to that termed San Andreas. No? I think there's a picture of San Andreas fault along with this frame that we are going to share. So let's have the different faults, the types of faults, and then after that, we move on to earthquake. So we have here a hanging wall and a foot wall class. What's the difference between a hanging wall and a foot wall? Notice the shape of a foot wall versus the shape of a hanging wall. Please see the difference, class. And the position of your foot wall and your hanging wall determines the type of fault present in that said plates. Again, the difference between the types of fault is the position of your hanging wall and your foot wall. For normal faults, the hanging wall is below the foot wall. For normal faults, the hanging wall is below the foot wall class. Okay? So we have here pictures of normal faults. These are examples of normal faults. Huh? Um, ridges is an example of a normal fault. Um, something like the one you can see in Loon when there was that earthquake that hit Bohol last October 15, 2013. It created a normal fault. It created a scenario wherein the the part of that land moved, and then the elevation was creating a slope that generates a normal fault. Okay? The normal fault again has the hanging wall below the footwall. So this is the ano. Hanging wall is below the footwall. That's the normal fault. But when you talk about reverse fault, also known as thrust fault, the hanging wall right now is above the footwall. The hanging wall is above the footwall, much like creating a canyon. Ano, not canyon. Creating a cave-like structure. The one near the ocean. That's a reverse fault or thrust fault. The footwall is below the hanging wall. Okay? The definition is relative to the footwall and to the hanging wall. Examples of thrust or reverse fault we have here. This one. Pictures of thrust fault and or reverse fault. In your place, have you seen a thrust fault or a reverse fault? Notice fault class is just simply a crack or the discontinuity of the lithosphere. Probably if you will travel to Carmen and then you pass by the road of Bilar, you'll see some faults there along the carved portion of the mountains. You can see cracks that might look like a normal fault or a reverse fault. The third classification of fault is known as the strike slip fault. There are two kinds of which, the left lateral and the right lateral. The right lateral, also known as the dextral fault, and the left lateral, also known as the sinistral fault. Please take note of the terms because it is not located in your module class. How will you know if it is a right lateral or a left lateral? How will you know if it is a right lateral or a left lateral class? Assume that you are going to position yourself somewhere here. If so nakadire, natindog ha. And then you're facing there. You're facing there. If the right portion of the plate goes to you, where the left goes towards or away from you, then this is a right lateral or dextral fault. But if this is positioned to you, facing still there, if the left side of the plate goes towards you, while the right side goes away from you, then this is left lateral. That example is also located in your in your in your module class. By just looking at the module, look at the module as if you're looking at the two plates. The left lateral, the left side of the plate goes to you, while the right side goes away from you. That is left lateral. Right lateral, when the right portion of the plate goes towards you, while the left side goes away from you, then that is right lateral. Whichever goes towards you, that's the name of the type of strike slip. Okay? Kung ang left side badungi mo, that's left lateral or sinistral. Kung ang right side sa tectonic plate goes towards you, then that is the right lateral or dextral form. Question? Clarifications? Please unmute yourselves if you have a clarification. Yes, Rainiel? Wala. Rainiel just unmuted himself.
Excuse me, Sir Jet.
Yes?
I will you know again if that's a footwall block or a hanging wall block, sir.
Okay, let me show it in this way. This is a footwall. Okay? This is a footwall. Kining inani ang shape. To know if it is a footwall, drawing yun na nagtiil. It's a footwall. That might be the clue that can be written there. So it's like a foot. That's a footwall. Hanging wall, it's like hanging, something like that. Some parts of the lithosphere hangs above the horizontal. This is hanging fault. A cliff is a good example of a hanging fault. Get it?
Thank you, sir.
Okay, footwall, hanging wall. Question? Other clarifications? Thank you, Ralph, for that concern. So soon as you have one, please unmute yourselves and we will entertain your concern. Okay. Welcome, Patrick, for our class. Patrick's just joined our class. Turn on your camera if you can, Patrick. If you cannot, I will turn off my camera. Thank you. So let's proceed. Pag may tanong, kindly ano ha. These are pictures of a strike slip fault class. So notice how a strike slip fault looks like. No? There's a disembarkment or this junction of a road of the railroad. There's a disjunction of a pathway of water, perhaps if this is a pathway of water. This is an example of a strike slip fault. They go lateral, either right lateral or left lateral. If that is a normal fault, you'll create a slope. If that is a reverse fault, you'll create a cliff. And if it is a strike slip, then the land is just fair on the horizontal, but it moves sideways, either right lateral or left lateral. That's the difference between the three types of fault. Again, normal fault, the hanging wall is below the footwall, or it created a slope. Um, Reverse fault, the hanging wall is above the footwall, or it will create a cliff. And if it is a strike slip fault, it is just simply on the level of the horizontal, but it goes sideways, either right lateral or left lateral. And movement of these faults will create a trembling sensation of the ground known as earthquake. Most news, if there's an earthquake that will occur in a place, they will mention the word epicenter. But that epicenter class is the first point to where the earthquake is felt in the Earth's crust. The point of origin of a certain earthquake, which is located under the lithosphere, is known as the focus. But the first part to where the earthquake will be felt in the above crust is the epicenter. Please see the difference, class. The point of origin of an earthquake is the focus. The point of origin in the Earth's crust of that said earthquake is the epicenter. Where was the epicenter of the earthquake last October 15, 2013? Can you remember? Somewhere in somewhere in Antequera, Serabulones, no? Is the epicenter. Somewhere there. Seismogram and seismograph are the instruments that determines the movement of the tectonic plates. What's the difference between a seismograph and a seismogram? The seismograph is the one below. The seismogram is the machine itself. Again, the seismogram is the machine. The seismograph is the lines that will create the ang tawag mo dyan? The, 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 the amplitude, the waves, the lines that will create the waves. Okay? Who created the seismograph? Let me go to the book and I will tell you the name of that person. Because I think I did not write it in the module. No, I did not write any information about a seismograph and a seismogram in your module. So this is the definition of a seismograph, class. It is an instrument that detects and measures the wave. Okay, that's the seismograph. The seismogram records the earthquake. Bali pala, class. Bali, bali. So the seismograph is this one. The seismograph is the machine, while the seismogram is the recording. I stand corrected, class. The seismograph is the machine itself that records the intensity of the earthquake, and then the seismogram is the one that records the earthquake's wave patterns. Okay, the amplitude and the crest and the trough. Good thing I asked the book about its definition. Okay. So let's continue. So we have here examples of patterns, wave patterns from a seismogram that was recorded when an earthquake that is going to be recorded when an earthquake will hit a certain area. No? So here are um, samples of earthquakes that will be located. How are they being located, class? Of course, they are being located by way of knowing the wave patterns. And these wave patterns has a certain origin, and that is where the epicenter comes in. Okay? I have here a record of the destructive earthquakes that hit the earth, in particular the Philippines as well. So I'll just give this to you as something to look forward to as a form of research. Okay? But just have it written in your book a note. Okay? For example, August 15, 2007, dated August 15, 2007, with a magnitude of 8.8, there's an earthquake that hits Peru. No? Again, May 12 of 2008, an earthquake with a magnitude of 7.9 hit China. And then I think this is quite famous because there's a great destruction and a lot of people was killed during the earthquake that hit Haiti in the year 2010, no? With a magnitude of 7.0. And then that earthquake that hit Japan when there's a big tsunami that engulfed the Bay of Japan, which is dated March 11, 2011, with a magnitude of 9.0. Imagine that. And last October 15, 2013, the one that hit Bohol with a magnitude of 7.2. So please take note of some records of strong earthquakes as we are going to progress with our discussion. Then probably a good FYIs might be done by research. Okay, so you do your own research there.
Sir,
Yes. How is this? Yes, Shania.
can you repeat what you said for the dates, sir?
If you turn
From
on
the
your camera,
top.
I will repeat what I said. Ayun. Okay. Number your papers 1, 2, 3, 4. Start with Peru, China, Haiti, Japan, and Bohol. Peru, China, Haiti, Japan, Bohol. Okay? So let's start with Peru. Peru with a magnitude of 8.8. We'll talk about magnitude later, but just write it there. Magnitude 8.8. Date August 15, 2007. China, magnitude 7.9. Date May 12, 2008. Haiti, magnitude 7.0. Date January 12, 2010. Japan, magnitude 9.0. 9. Date March 11, 2011. Bohol, magnitude 7.2, date unknown. What's the date there? I will not forget the date because my baby there was still months old. When that earthquake hit Bohol, my baby was walang kamuwang-muwang. No? I carried my
Japan, sir, no,
baby
kay 9,
outside of the
9
house.
magnitude, sir.
No? With that
Sir,
said,
is
ano,
Japan 9, 9.0, sir.
yes, Daniel.
The Japan's magnitude, sir, no, just 9, na, sir, no.
9.0.
Just 9.
Yeah. Any other question? With regards to the other details like the people who were dead, the people who were missing, the lives lost, please extend your readings there. You can just have to type it type it in Google, in Goggles, and in Goggles will give you everything there. Okay, so we have here the global seismic activity, which is locating the, anong tawag dito? Have you seen the movie Pacific Rim? Have you seen the movie Pacific Rim? The one with the
robots,
kaiju and the Jaegers. Yeah, the robots are
kaiju, the
the
robots.
Jaegers. The monsters are the
Jaegers kay
kaiju.
hunters in German. Yeah.
Hmm.
Jaeger, mean Eren, sir, from Attack on Titan.
And where was that shoot? Or where was that shoot now? What continent was that movie being shot?
Asia.
Asia. Yeah,
Asia.
Asia. And what is that in relevance to our lesson?
How the kaijus enter the outside world.
And what is their purpose?
To destroy or to
Destroy
get
what?
more.
Destroy what?
The world.
The world. Actually, class, if you just thank you for participating in my nonsense questions, Daniel. No, actually, class, the purpose why the kaiju came out of the earth is to bring back the so-called phenomenon that destroys the dinosaurs. The bombardment of asteroid brings about volcanic eruptions, and these volcanic eruptions covers the earth with gases, and these gases traps the carbon dioxide that is in our atmosphere, thus limiting the oxygen so as life to continue. And that's where dinosaurs were dead. It's not because they're hit by an asteroid. No, like one dinosaur was killed because it was hit by the asteroid. No, the asteroid generates a phenomenon known as volcanic eruptions, and the and the and the excessive smoke generated by these volcanic eruptions leads to the atmosphere being deprived of oxygen. Thus, dinosaurs were dead. What is the main purpose of the kaiju? They wanted to hit Mount Fuji to generate a link between the other volcanoes to erupt, because this is, I think, Japan. I hope that I am pointing the right direction. This is Japan here. Of course, Philippines is here, diba? Philippines is this one. Oh no, that's Indonesia. I think Philippines is here. Philippines is here. Japan is here. The kaiju wanted to go to Mount Fuji so that they will. It's like igniting Mount Fuji to erupt. And when Mount Fuji will erupt, all the other volcanoes that is located in the Pacific will also erupt. That is why these volcanoes are known as the Pacific Ring of Fire, because this surrounds the Pacific Ocean. That's the name Pacific Ring of Fire. It is named so because the Pacific Ocean is surrounded with active volcanoes. Get it? So once Mount Fuji will erupt, it will create a chain reaction to the other volcanoes that will also erupt. That's the main purpose of the kaiju. They will destroy the
Also
earth.
true po, sir. Also
Ah?
true po, sir. It's also true po, sir, that it will really actually happen po, sir, if Mount Fuji will erupt all the others po, sir. Will erupt.
Let me ask you from that perspective. Will it be true or not? I will ask you before I will answer will answer you on that one. Will it be true? If Mount Fuji will erupt, will also the other volcanoes will erupt? Yes or no?
It's not true. It's just Hollywood fiction.
You know, movies
Not
are somehow exaggerated. Perhaps there is 1% proof to it. But how can a volcano will erupt? There is an activity in the underground. It has nothing to do with one volcano to the other. There is an activity in the underground, and that activity is the movement of the tectonic plates, the movement of the fault. When this fault moves, if there's a leak from that said movement, magma will escape. What is magma again? Molten rock under the lithosphere. When they escape, their vent out is a volcano. They will vent out to the volcano as a form of lava na, because that is already outside of the Earth's surface. But in that case, if that will give you a greater tremor, let's say for example, the plate here will move. The plate here will move because of a greater there's a greater fracture of the Earth's crust, then all the others will also move. Then the Earth will be constantly moving. But that doesn't mean that because of the volcanic eruption, does the other volcans will move? It's not. It's because of the tectonic movement in the surface of the Earth. I mean, in the lithosphere. Again, it's not because of one volcano. It's not because of one volcano that the other volcanoes will erupt, but it's because of the tectonic movement. Get it? If the tectonic movement of Mount Fuji is related to the other volcanoes, then probably it's because of the movement, but not because of the activity of Mount Fuji. Then how come we have islands? How come we have 7 continents? In the old times, let's go history for a while. Before we have the 7 continents, we but have one single landmass, and we call it P. George Dulalas. I think John Patrick Lungat wants to answer.
Pangea, sir.
Panjaya are
Pangea.
you John Patrick Lungat? My God, Daniel. Thank you, Daniel, for the answer. I was about to ask John Patrick and George Dulalas, but you are the savior of your friend. No, best friend mo ni George Dulalas, Daniel. Good. Okay, so the answer of Daniel is correct. Panjaya. Spell Panjaya, George Dulalas.
Uh, Pangae. Ano, EA.
Oh. PNGA. What again? P.
Pangea.
Wrong. It's like giving pan to your Ate Jaya, di ba? Panjaya. Pangaea. Pangaea. That's the spelling of Pangaea. Okay? Pangaea. Pangaea. Pan ni Ate Jaya. What is that Pangaea? That's the single landmass to where our Earth had before. But how come this turns into 7 continents? Because every year, because of some tectonic activity, there's movement of the Earth's crust. Okay? Climate change perhaps allows the water to fill in the gaps between this land, but the tectonics moves from time to time. Even right now, the tectonics are actually moving. Perhaps 1 millimeter a year or 1 millimeter in 10 years, but they are constantly moving because under the Earth's crust is the mantle, di ba na may mantle? And in that mantle lies the upper mantle and the lower mantle. The lower mantle is liquid. The upper mantle is solid while the lower mantle is liquid. And in that lower mantle lies the so-called convection current. We had that convection before, ba? This convection current is the movement of the temperature up and down, creating a current here. And this convection current allows the plates to move from time to time. If these are plates in your Earth's crust, they are moving because of the convection current. If plates will collide with each other, earthquake occurs. If plates will move away from each other, earthquake also occurs. These are sensations that we felt from time to time, but since these earthquakes are minimal, we might not felt it, but actually, there are earthquakes from time to time. These tremors might not be felt because these are just minimals. Those which we can feel are the stronger earthquakes. Example of which, the October 15, 2013 phenomenon that hit Bohol. Something like that. And before class, Earth was just made of a single landmass, as a single water as well. If this is the Earth, this is Pangaea, all of which is also water. Wala Atlantic Ocean, wala pa Pacific Ocean. It's just the same. It's just a single ocean because we only have a single landmass. You also have a single water body of water. And the name of the single body of water is blank. What is the name there? If Pangaea was the single landmass, the single body of water is named as
What are the nouns in this sentence?
wala. Starts with letter P as well.
Is I a noun?
Pan pod ang gasugod. Pan,
Is I really a noun?
ta,
You have friend?
pan, ta. Clarice, you know the answer
Is
there?
there only one noun in the sentence, Jeka?
In several references, this debatable as to which is correct and which is not, but both are acceptable. Pantalasa or pantalesa.
I a noun?
No, but the most accepted one is pantalasa. Pantalasa is spelled P-A-N. I'll write it here. P-A-N-T-H-A-L-A-S-S-A. Pantalasa.
Is there only one noun in the sentence?
Ang
When
pan
I
ni
declare-
Jeya is panlasa. Ayun. Sarot. Laser jet. Again, the spelling is pantalasa.
Is there only one noun in the sentence?
Question? So why did we went there, no? In fact, we just have to talk about earthquake.
Carlos, is there only one noun in the sentence?
Okay, let's now make use of the
You have another
Mercalli
noun,
scale
which is,
and the Richter scale class. What is a Richter scale and what is a Mercalli
now
scale?
you want to write the noun
A
which is,
Richter scale measures the
I
magnitude.
paid what?
Again,
What's the answer?
Richter scale measures the magnitude,
I
while the
paid what?
Mercalli scale measures the intensity. What is the difference between a magnitude and an intensity? I hope that your module has that definition there. Here,
Right.
last part, page 2 of your module, you have there earthquake measurement. No, Mercalli and intensity. The Richter scale, letter shift number 4. If you're with me, letter shift number 4. There are two magnitude scale and one intensity scale. The Richter scale is the moment magnitude scale for magnitude, and the Mercalli scale is for intensity. The Richter scale is numbered 1 to 10, and the Mercalli scale is numbered 1 to 12. No? I think.
Given, Alex.
Okay, what's the difference between
To the word
magnitude
friend,
and
the word
intensity
friend,
class?
the word friend.
Excuse me. When you talk about
So here, we have
magnitude,
another
it's the
receiver.
strength of the earthquake. Simple as that. The strength
If the
of the
direct
earthquake,
object is the receiver
which
to
means
action,
from the earthquakes that hit Peru, China, Japan, Haiti, and Bohol, which is the strongest?
here, there is a receiver of the
It
Japan.
is the,
direct
Japan.
object.
yes,
Japan.
because of the magnitude
There
9.0.
is a noun
But
in
between
sentence.
the
So wait, wait.
earthquakes that
There's a
hit
noun
the
in
5
sentence
countries,
which is considered
which
as the receiver
is
direct
of the
object.
higher
Now,
intensity.
we
When you
answer
talk
the
about
question,
intensity class,
whom was the
intensity
higher
is the
given?
amount of
The
destruction
answer is
that was
that
made by
friend
the
B.
earthquake.
indirect
Magnitude is the strength of the earthquake, but intensity is the measure of the
So you
destruction
have
that was made by that said earthquake. So, for example, intensity 1, we can just feel it
the
from the
indirect
ground.
object, the receiver of
Huh?
the direct object.
Intensity 2,
And
perhaps,
the preposition, the one that we had
we can
earlier,
feel it
it's
like
negative.
our
So the
chairs are
receiver of
moving.
information
Intensity
started by
3,
the Greco spectrum.
maybe it's some of the chandeliers will move.
Receivers in
Huh?
grammar.
If it is intensity 9, what do you think will happen there?
And again,
Huh? Intensity 9 perhaps
is
will
a
give you
noun, it's not a noun.
destruction of buildings, like the movie San Andreas.
As they are
Intensity 12, perhaps every building is toppled down together with the trees and everything.
subject,
Huh? But
direct
let's not say
object,
it will reach intensity 12 because I think everyone will be brought back to the ground.
object. Have
But the
another
magnitude is the strength of the earthquake. It's just how strong the earthquake is. And that strength is determined by the Richter scale. The Richter scale will determine how high the amplitude of the wave patterns from that said earthquake. Okay? So Richter scale goes from 0 to 10. I think that is also found in your module. Whereas Mercalli scale is ranging from 1 to 12. So let me read to you some of the Richter magnitude values. When you talk about 2 below, generally felt, 8 and above destroys everything near in the community. I think you can have the PEIS or the Phoenix earthquake intensity scale that can be downloaded in Google Images. So as with the Richter magnitude value. You can have this as notes taking. No? I'll just give you this as an assignment. I purposely did not have it in the module because it's really quite long class. And there are pictures along with it.
the subject, correct.
Okay, talking about plate boundaries, these are your plates class. I also mentioned the term lithosphere a while ago. So these are the terminologies that I have it here. Continental crust and Earth's crust, let's now differentiate between the two. When you talk about the Earth's crust, it is a thicker version compared to the continental crust. The continental crust is quite thin compared to the Earth's crust. I mean, the oceanic crust is quite thin compared to the continental crust. When two continents collide, or rather when two continental crusts collide, it will create a mountain or a val or a hill or mountain ranges. But if two oceanic crusts will collide, it could either create a trench or it will create a volcano in the beneath ocean. Okay? But most often, two oceanic crusts will collide, generates a trench or a ridge or a mount or an oceanic ridge. What is this red flowing going on top? This is the magma class. And then this is the asthenosphere. Asthenosphere is the zone between the lithosphere and the upper mantle. It's the boundary between the lithosphere and the upper mantle, asthenosphere.
Complement. We do not read that as complement. A complement is different from a complement. And since this is a noun,
So here is an example of
predicate noun or a
Google
predicate
Earth view of
nominative.
the place in Sumatra. No?
It's a complete
This is
verb.
the
Predicate nominative.
mountain ridge or the mountain ranges, but this is located in the, I think this is in a water level. No?
A complement. So again, look
I'm
at
not quite
that.
sure. Not familiar with
My
this one.
friend is Christian. Friend is a noun.
Where particularly is Sumatra? Is it in Indonesia?
Christian is a noun. It takes on the
Sumatra.
function as a complement. Specifically, the predicate nominative.
Back to you, Mike. Okay, let's proceed with the converging plates. Converging plates will create mountains or it will create mountain ranges. One of the examples of a converging plate is the Himalayas. Huh? I think Himalayas runs from India to China. It is in the boundary between India and China. And then diverging, if this is converging, diverging is towards each other or away from each other. Diverging plates will create
in this sentence.
mountain ranges as well. However, most diverging plates will create trenches.
What is the function
A
of
good
this
example of a trench that is created by a diverging plate is the Mariana Trench. I think in the next lessons we will also discuss volcanism. So probably we will continue discussing the plates when we go with volcanism. So this is a converging plate class. It will create a mountain range.
Why? What?
And then
what's the
probably later we'll see a
definition of
diverging plate.
definition? You kind of built it there and said,
I think this picture about Pakistan, this is the Himalayas.
when you try
Di
to
ba
answer
Pakistan, India, China? This is the boundary to where the Himalayas was being made.
is there some form of doubt?
Transform plates is like a straight slip fault. Transform plates slide past each other.
Because obviously this is
Um,
a subject.
San Andreas is a transform plate. This is a picture of a San Andreas fault line. Yun.
Yona.
And then we have here a picture of plate boundaries. These plate boundaries, if they move away from each other, it will create another continent.
The main friction in the original
This is the Australian plate. This is the Eurasian plate. Eurasian plate is Europe and Asia.
Just interchange the
And then South America, North America, Ara um,
the complement
Arabian plate is Africa.
answers the questions
No?
what or who.
So these plates
Just like
are
your
now the
direct
result
object.
of the 7 continents that move away from each other.
The direct object
And that theory was guided by the tectonic plate theory or the continental drift theory. Not much with this one. Class.
different from this.
Liquefaction.
These arrows signify that the subject refers to the
So your module is centered on faults and earthquakes. So what are the 3 types of faults again? The 3 types of faults we have the normal fault, reverse fault, and the strike slip fault. The difference between the 3 is the movement of the hanging wall and the footwall. I mean, the difference between the 2 normal and reverse fault is the movement of the hanging and the footwall. Okay. So um, we also have the strike slip, left lateral and right lateral, also known as the dextral and the sinistral. Please have them memorized. And then the do's and don'ts of having an earthquake can be discussed further when we have it in TLE, no? It's part of the TLE lessons. But allow me to share some inputs of the do's and don'ts or the before and after earthquake. Before an earthquake, class, what will you do at home? Before an earthquake, what will you do at home, class? Your parents are actually doing this after the earthquake that hit Bohol. Prepare medical kit, store supplies, like store supplies means canned goods, those that will not spoil for a couple of months. Do not store vegetables because they will spoil. You have it as canned goods, noodles in particular, uh, those which can last for a couple of months before you can use it. Okay, and then prepare an evacuation plan just in case an earthquake occurs. No? How about during an earthquake? Right now, there's an earthquake, Simbako. What will we do then?
Here is a
The cover and hold.
Yun, duck
The
cover and hold.
over hold.
If you see a duck, you hold the duck and you cover the duck. Charot. Duck means duko, cover your head. Not just simply put a paper cover. No, cover your head. Protect your head because if your head will be hit by a falling debris, good luck to you. And then hold something strong. If possible, go under the chair, go under the table, or go to an area which is open so that no falling debris will go onto your head. And how about if and when the earthquake is done? What will you do then? If the earthquake is done, what will you prepare?
So we now have subject,
Prepare for.
Indirect object.
Listen to radio,
Prepare for
For.
aftershock.
Very good.
aftershock.
Still we have
Listen to
Because
radio.
after an earthquake, there is always an aftershock. Okay?
this one.
How can you explain an aftershock? Much like the same with a wave in a certain ocean. Diba, after a wave, there's a minute wave that goes back because that's the aftershock, the shock after the main shock, aftershocks. And then it will record for more than 100 aftershocks if the earthquake is that strong. What else are you going to prepare? According to Daniel, prepare a radio or listen to a radio.
Jillian
And then you're also going to prepare for some injuries. Probably it might not be to you, but for some other people in your vicinity, prepare the med kit you prepared beforehand and then treat injuries if possible. Treat these injuries since it might not be that deadly, but at least the contamination is not is prevented from such an injury. And then the most important thing, aside from the radio, keep all lines open. Cell phones or anything that will lead you to news of several agencies that will give you other concerns relating to the earthquake itself. Okay. Questions? Clarifications? There's a difference between the STs that we will have in the first quarter with the STs that we will have in this quarter. Maybe there are more essays in this summative test that we will have since there are a few computations that we will have, but less, more on memorization and also understanding with the said lesson. Okay.
To the word bread.
Yes, Daniel,
I'm
do you
not
have a
sure.
concern?
Additional
You can
information.
leave na
Tama, sir.
Daniel. You can leave na Daniel.
More details of the noun
You
that
can leave na
comes
Daniel.
after. Like what it's doing here.
Daniel, please leave the class.
My friend